Can you see the screen? No. Let me share. Okay.
Yes, sir.
There is a difficult derivation, that is banking of the road. Okay. The next is banking of the road. I will write the heading here. Banking of the road. Banking of the road. Banking means lifting. Understood? Banking means lifting. Have you seen in the turning, if there is a turning, suppose there is a sharp turning. If there is a sharp turning, a vehicle is supposed to move like this. There is a sharp turning. Then you might have noticed that the outer boundary of the road, I will show in this diagram. This is the outer boundary. This outer boundary of the road is lifted a little bit from the horizon, from the ground. Understood? Look at this diagram. The upper boundary of the road, this is the road. Okay, this is the road, and the vehicle, this vehicle is going to take a turn. This car is going to take a turn. And you might have noticed that if there is a sharp turning, it will be better. It will be better if we lift the outer surface of the road a little bit high, I mean above the ground. This lifting, understood, this height may be something like maybe some say 20 centimeter or 30 centimeter, like that. There is a small lifting. Have you noticed this? This is said to be banking of the road. Why we are lifting the outer surface of the road? Can you tell me the reason? Anybody? Why we are lifting this one a little bit, only the outer surface of the road? You please respond. Anybody? Can you tell me the reason?
Or else it will skid.
Yes. If there is no lifting, I will show you. Suppose this car is moving at very high speed. Let it be car. Can you see the diagram? Let this car taking a sharp turn. So if it is taking a sharp turn, there is a possibility that if there is no sufficient friction, there is a possibility that this car is slowly skid away from the road. Understood? If it is moving at very high speed, taking a sharp turn, there is a chance that slowly this car may be slowly skidding away from the road. Is it correct? You please respond. Nadasha, all of you clear? So how can we prevent it? So if there is a sharp turn and this car is moving at very high speed, there is a chance that the car is slowly skidding away from the road, moving away. Understood? So if we lift like this, because of the weight of the car, due to the weight of the car, such possibility can be avoided. Understood? This car find it very difficult to skid away from this path because of the weight of the car. Understood? So that's why, okay, we are lifting the outer surface of the road a little above from the ground. All of you clear? Understood? Please respond.
Yes, sir.
Okay. So you understood the reason. 1 minute. Okay. So just a minute. Okay, so the title is okay. Let me join from my mobile. I want to join from my mobile. 1 minute. So the title is Banking of the Road. There is a derivation, the safe speed. What should be the safe speed so that the car does not skid? So the formula I am going to derive. Banking of the road. The derivation is important. I cannot avoid the derivation because it will be asked in exam. The derivation is 1 minute. So I am going to explain the derivation. Okay. So this car will have a weight. Understood? This car will have a weight. Just a minute. Joining from my mobile. Yes, this car will have a weight. You agree with me? You please respond. This car will have a weight. Suppose this car has the mass m. What will be the weight of this car? The weight will be vertically downward. You know that. It will be mg. The derivation is very difficult. If you don't understand the derivation, you have to tell me. Okay? Understood. So the weight of the car, that part is clear. Suppose this angle is given to us. Suppose this angle is theta. You understood why we are maintaining this angle theta? In order to prevent the car from skidding away, okay, from the track. That's why we maintain a small angle, especially in the sharp turning. So the weight will be there. My objective is what should be the speed of this car? What should be the safe speed of the car? That is my objective. The car speed should be limited. Okay, if the car speed is beyond certain limit, if the car speed exceeds certain level, the car definitely skid away from the track. Understood? So I want to find out the maximum speed of the car, safe speed. So that is what I am going to find out. The derivation is very, very difficult. All of you please listen. I will repeat, don't worry, I will repeat. So definitely there will be a normal reaction. Normal reaction will be definitely be there. What do you mean by normal reaction? Anybody? I explained in the previous class. Anybody? Do you know the normal reaction? Nadasha, Aaron, Aryan. I explained the normal reaction in the previous class. Deva, do you remember the normal reaction? Forgot it. The normal reaction means, listen, the car exerts a downward force, understood. As a result, the plane, understood. This is road actually. Is it a road? Yes. This road exerts an upward force. Definitely, this road, this shaded one, this road exerts an upward or normal force on the car. That is said to be normal reaction. Understood? The normal reaction is necessary. If normal reaction is not there, because of the weight of the car may be going inside the, understood, inside the road. So in order to prevent it, in order to prevent the car from falling down, there should be some normal reaction. This normal reaction is the force exerted by which one? Exerted by the road. This road exerts an upward force on the car. If normal reaction is not available, the car will sink into the road. So it will be there. Okay. So normal reaction is the force exerted by the road on the car. You agree with me? Understood? You please respond. Nadasha,
Yes.
Aryan, you please respond. Nobody is responding. Deva, have you understood? Deva, till this step you are okay? Till this step you are okay. You please respond. I am discussing a very tough derivation. It is the most difficult derivation in this chapter. Okay. So mg and n both are okay. Understood? So any other force? Yes, there are many other forces acting on the car. I am showing the forces acting on the car. What are the different forces acting on the car? One force acting on the car is weight, mg. This mg is the force exerted by the earth. Earth is applying a downward force on the car. That is said to be weight. And the car experiences an upward force. This upward force exerted by the road. Any other force? Yes, definitely. This car is taking a sharp turn. Understood? The car is taking a sharp turn. So what happens is, definitely, if the road is smooth road, if the road is extremely smooth, definitely the car may slow. It has a tendency to move like this. Understood? A small tendency. You agree? You think practically, you can understand. Suppose there is a lot of oil. Suppose there is a lot of oil on the road surface. This car is taking a sharp turn. Definitely the car has a tendency to move away, skid away from the track. In order to prevent it, the friction plays an important role. The friction the friction between the tire and the road will be definitely be there. The friction is the force between the tire and road will be definitely be there. It is F. If F is not there, what happens? For example, it is there is a oil. Okay, there is a lot of oil on the road surface. If it is taking a sharp turn, definitely it will skid away. Okay, so the friction should be there opposite to that, so that that force, this one will be cancelled. It will not skid away. So friction will be another force acting on the car. The friction is the force between the tire and the road. Is it okay? Please respond. Is that okay?
Yes, sir.
Okay. Nadasha, you please respond. Anybody? Do you have any doubt? Tell me.
Sir, I can't understand, sir.
Which part you have a doubt? Please tell me.
Sir, that F.
F you have a doubt.
I see.
You think practically, Deva, you think practically. You are driving a car. You are driving a car. There is a lot of oil in the surface of the road. If you are taking a sharp turn, understood? This is a turn, but I cannot show in the diagram. This is a turning. The car is going to take a sharp turn. Understood? I cannot show in the diagram. The car is taking a turn. Understood? Taking a turn like this. If it is taking a sharp turn, it has a tendency to drift away. Understood? Can you think? Is
Yes,
that okay? Ah, yes. The car has a small tendency to move like this. Definitely, if there is a friction, not there. If no friction at all, the car has a tendency to skid away from the track. So the friction will be there. Understood? So the F will be against that. Is that okay? Till this step you are okay.
Yes.
Nadasha, മനസ്സിലായോ? Nadasha, Aryan, ക്ലിയർ ആയോ? ഞാനിത് വളരെ സ്ലോവിൽ ഡിസ്കസ് ചെയ്യുന്നുള്ളൂ കേട്ടോ. ഓക്കെ, നഡാഷ. കുറച്ച് മാത്സ് ഉണ്ട്. ദർ ഇസ് എ ലോട്ട് ഓഫ് മാത്സ് ഇൻവോൾവ് ഇൻ ദിസ് ഡെറിവേഷൻ. ഐ കനോട്ട് സ്കിപ്പ് ദിസ് ഡെറിവേഷൻ ബിക്കോസ് ഇറ്റ് ഈസ് ദർ ഇൻ അവർ സിലബസ്. ഇറ്റ് വിൽ ബി ആസ്ക്ഡ് ഇൻ എക്സാം ഓൾസോ. ഓക്കെ, എനി അതർ ഫോഴ്സ്? യെസ്, ഓൾ ഓഫ് യു ലിസൺ. There is another one. Okay. Let me do one thing. Let me draw x-axis and y-axis. I will tell you the reason why we are drawing x-axis and y-axis. I want x-axis and y-axis. Let me draw x-axis along the inclined plane. Let it be x-axis. And let me draw vertical axis in the direction of n. Let it be y-axis. Let me draw x-axis and y-axis. Let me split all the forces in the direction of x-axis and y-axis. We can resolve. Definitely I will repeat. Don't worry. Okay, I will repeat. We can resolve any force in the direction of x-axis and y-axis. All the inclined forces can be resolved along x and y-axis. This F need not be resolved. This F is along x direction. So F, I don't want to make any modification. The normal reaction is along y-axis, so I don't want to do anything with the n. F is along x direction. I don't want to make any modification. N is 1 minute. I will tell you. Let me draw x-axis and y-axis in another way. 1 minute. This is x-axis. All of you please listen. Let it be x-axis and let it be y-axis. Deva, don't worry, I will repeat. Okay, Nadasha, I will repeat. So let it be x-axis. This horizontal axis is said to be x-axis. This vertical axis is said to be y-axis. This mg is towards the negative side of y-axis. You will get the diagram. But this n is inclined force. N is inclined. So I want to find some angle here. 1 minute. N is perpendicular, right? 1 minute. N is perpendicular. Just a minute. N is like this. Okay. So let me do one thing. Let me draw a dot line like this. I will tell you the reason. There is no problem if I draw a dot line like this, and also let me draw another dot line like this. Okay, So I want this angle. Can you suggest what is this angle? Anybody? Forget about this x and y axis, no problem. I have simply drawn a dot line, vertical line, and a dot line, horizontal line. Can you suggest? Can you see an angle here? Can you suggest what will be that angle? Anybody?
Maybe it's cos.
Is it cos? Is it theta? How can I find out that angle? Is it theta?
Yes.
1 minute. Let me. Theta. It should be theta. Just 1 minute. This is. Okay. I can tell. 1 minute. This is theta. This is theta. 1 minute. My diagram is not so perfect. That is the main problem. All of you, please wait. Just wait. The theta, I will tell you the reason. 1 minute. Just wait. Just wait. Okay. All of you, please listen. All of you, please listen. This angle, let me draw F like this. No problem. Don't worry. Listen. This is F. This is frictional force. Understood? You can see that this angle will be 90 minus theta. I will delete it after discussing this. This angle will be 90 minus theta. You may zoom it if you have any doubt. You may zoom it. Can I say that this angle is 90 minus theta? Can you tell me the reason? Can you tell me the reason? This mg, let me extend mg. Let me extend mg. You can see a right angle triangle. All of you, please listen. Let me extend this mg. Let me extend this mg downward. You can see a right angle triangle. Can you see that? Yes, you can see a right angle triangle. This one is 90 degree. So if it is theta, this one should be 90 minus theta. In a right angle triangle, the smaller angle, understood. If one angle is theta, other one will be 90 minus theta. It is a property of right angle triangle. This one is 90. Okay, this one is 90. So if it is theta, this angle will be 90 minus theta. All of you clear? Please respond. All of you clear?
Yes, sir.
Sir.
Have you understood why this angle 90 minus theta? Have you understood the reason?
Yes, sir.
Understood. Now listen. Aaron, Aryan, everyone, Nadasha understood. I am repeating this angle 90 minus theta. You understood. Okay, listen. You understood that. Now listen. Let me highlight another one. This total angle, highlighted one, you may zoom it. If it's not properly visible, you may zoom it. This total angle, it is 90 degree. This highlighted one. This yellow colored one. Understood? This total angle is 90 degree. This is going like this, perpendicular. Understood? This highlighted one is total angle is 90. So if it is 90 minus theta, this should be theta. You can zoom it. Please zoom it. You please zoom it. If it is 90 minus theta, this should be theta. Why? Because their sum must be 90 degree. That is the reason. This yellow colored angle is 90 degree. You can see it. If you look at the diagram, you can see that. This yellow colored total angle is 90 degree. So this one is 90 minus theta. Then this one should be theta. Because their sum is 90. Their sum must be 90. So their sum right now, their sum is 90. So since it is 90 minus theta, this should be theta. So have you understood why this angle is theta? Please respond.
Yes, sir.
Aaron understood. Deva, you please respond. Deva, do you have any doubt? This angle theta, understood?
Sir, understood.
Understood. Nadasha, okay, clear. Now listen. My discussion take time, but if I must discuss slowly, otherwise you cannot understand. Look at this angle and this angle. Are they opposite angle? Are these two angles
Yes.
opposite? Yes. This angle is theta, then this should be theta. They are opposite angle. You studied in 9th standard. The opposite angles are equal. Understood? If you have two lines are intersecting, if this angle is theta, their opposite angle is also theta. Okay, so if it is, since it is theta, this should be theta. Please zoom it. I don't want to enlarge the diagram. I cannot enlarge the diagram. There is a lot of steps required. Please, you can zoom it using 2 fingers. You can zoom it. Okay. So this one is theta. All of you clear? Please respond.
Yes, sir.
Yes,
Okay.
sir.
You can make full screen and zoom it using 2 fingers. Zoom it. So this one is theta. Now, all of you please listen. Now this angle is theta. Now all of you please listen. This n, make an angle theta with this dot line, this vertical axis. Let me call this dot line as a vertical axis. This n, make an angle theta with this axis. In the chapter vector, when I explain the chapter vector, I explain the resolving a vector into 2 parts. I explained that. If you don't remember, I will discuss once again. Suppose I have a force or displacement, something is there. F is a vector quantity, and there is an axis, whatever may be, whether it is x-axis or y-axis, whatever it may be. Suppose this F, make an angle theta with this axis. F is a force, displacement, whatever it may be, making an angle theta with this dot line, with this axis. Then the component or part of this force and on this axis. The part of this force on this axis will be, I have explained the derivation also. If you don't remember, just memorize right now. So there is a vector making an angle theta with an axis. Then a part or component of F along this axis will be F cos theta. Okay, and let me draw a perpendicular axis. Let me draw a perpendicular axis like this, and the component of F, the component of F along this axis is F cos theta, and the component of along this axis will be F sin theta. Actually, I discussed already. So remember, the F cos theta is the most important one. Once you have written F cos theta, the other one will be F sin theta. So F is there, making an angle theta with the one axis. Then the component of F along this axis will be F cos theta, and the perpendicular component will be F sin theta. Understood? So we studied that. Okay, we have already studied that. So let me write this formula. After that, you can ask me doubt. So F is actually the resultant of, we can say like that, F is actually the resultant of F cos theta and F sin theta in simple language. I mean, somebody pushing a body, there is a body kept here, somebody pushing a body with the F cos theta, another person pushing a same body with the force F sin theta, their resultant will be F. So F is split into 2 forces, F cos theta and F sin theta. And in the same way, N is making an angle theta with this axis. I don't say X or Y axis. This N making an angle theta with this axis. The component of N or part of N on this axis will be N cos theta. and component of and the perpendicular component. The perpendicular component will be this one. It will be n sine theta. So what I am saying is n is actually the resultant of n cos theta and n sine theta. Two persons are there. One person applying a force n cos theta upward, another person applying a force n sine theta like this. Their resultant force will be n. Okay. So you please look at the diagram once again till this step. Till this step. If you have any doubt, you please ask right now. Okay. Please look at the diagram once again, and if you don't understand any term or any angle, any letter, you please tell me right now. I will explain once again. Please. If you are 100%, tell me.
N cos theta and sin theta, sir.
You have a doubt about n cos theta and n sin theta?
Sir.
Deva. Actually, I think you missed one chapter. Okay, missed one class. I think so. This one actually I explained when I introduced the topic vector. Please mute. Tell me.
That sin theta and cos theta, sir. What about that n? How it will be coming, sir?
How? The reason the proof I have already discussed in the class. Okay. The derivation of f cos theta and f sin theta I have already taken in the class. You were absent. Okay. I think you missed that class. I will send that recorded class. Okay. You please watch it. Okay.
Sir, I have attended that class, sir. I know that f sin theta and f cos theta, sir.
Then
I'm
tell me.
in the diagram, I'm asking how we will represent f into n sin theta and n cos theta, sir.
That is what I am discussing. Listen. Look at this diagram. The diagram drawn in the bottom side. There is a force F. The component of F along theta, you may say like that. Okay. No need to say x-axis, y-axis. Never say like that. There is a force. There is a vector. The component of the vector along theta, you may think like that. The component of F in the direction of theta. I mean this one. You have to memorize that the component of f in the direction of theta will be f cos theta. Okay. So in this diagram, you see the diagram, there is a force n. There is a force n, the component of n in the direction of theta. The in the direction of theta means this vertical one, right? The vertical one is in the direction of theta. So the component of n in the direction of theta will be what? N cos theta. The same technique I used here. F is rotated theta. What is the component? You may think like that also. F is rotated an angle theta. What is the component in that direction? F cos theta. The same way, n is rotated through an angle theta. The component in that direction, n cos theta. So that n cos theta is okay for you? N cos theta?
Yes, sir.
And the other component, one component n cos theta you memorize, the other perpendicular component, perpendicular to n cos theta. The other component will be n sin theta. So what I am saying is n is actually the resultant of n cos theta and n sin theta. Understood? That is what I am saying. Okay, Nadasha, ശ്രദ്ധിച്ചോ? Nadasha, ശ്രദ്ധിക്കുന്നുണ്ടോ? എന്തെങ്കിലും Rakshana, you join right now? Rakshana?
No, sir, I joined like 5 minutes after the class started.
Okay. So now in the same way f is there. Understood? F is there. F is there. Let me draw horizontal axis like this. I think you are not confused with this diagram. Okay. Let me draw a dot line, horizontal axis like this. What is this angle? You can zoom it. Okay. You please zoom it. What is this angle? Can you suggest? What is this angle? Please tell me. This angle is theta. Please, all of you, please zoom this picture. All of you, please zoom this picture. If it is theta, this one is also theta. You agree with me? Please respond. All of you, please zoom it. If it is theta, this
Yes,
should be
sir.
theta, because this dot line and this one are parallel. This dotted one and this one are parallel. This theta, this one also theta. Alternate angle, alternate angle. So the friction is going along the line, understood? Along the inclined plane. The friction is going like this. The frictional force is going like this. F also has component. This F is rotated through an angle theta. You think like that. This F is rotated through an angle theta. So the component of F in this dot line will be F cos theta. F is rotated through an angle theta. The component of F in this direction will be F cos theta. And the perpendicular component. F has two components. One is F cos theta. F is rotated through an angle theta. Hence the component will be F cos theta. And F has another component. I will draw a separate diagram here. Don't worry. For the time being, you zoom it. Zoom the video. Picture. F cos theta will be towards left. F sin theta will be downward. So look at the diagram F. F is going like this, inclined direction. F is rotated through an angle theta. The component of F in that direction will be F cos theta. And the perpendicular to that component will be F sin theta, downward. Okay. You please look at this diagram. All of you please zoom the diagram and watch it. And if you don't understand any term, you please ask right now. If you are 100% clear, you can raise your hand. Deva, Aaron, all of you clear. Rakshana, have you understood? After this class, yes. After this class,
Sir,
tell me.
is n sin theta equal to f cos theta?
You have do you have a doubt about F cos theta and F sin theta?
No, sir. I'm asking if n sin theta is equal to f cos theta. Like, will it have the same value?
No, F cos theta and F sin theta will not have the same value. They have different values.
No, sir. N sin theta and the f cos theta.
F cos theta and
N sin theta.
N sin theta. No. They are in the same direction. F cos theta and N sin theta, the two forces are in the same direction, but their magnitude will not be equal. Okay?
Yes, sir.
Okay. Now listen. So there are plenty of forces acting on the car. Okay. After this class, don't worry, I will send the recorded class. Okay. So you have to understand the derivation. So this derivation is there in our syllabus. I cannot skip it. So let me draw this diagram. Not car. Let me draw all the forces again. There is a car. This dot represents car. What are the different forces acting on the car? N cos theta, this N is replaced by N cos theta and N sin theta. I told you that N is the resultant of N cos theta and N sin theta. So the car experience N cos theta upward, look at that diagram, and N sin theta towards left. What I have done is, the normal force N is replaced by N cos theta and N sin theta, because N is the resultant of N cos theta and N sin theta. So N is replaced by these two forces. Let me draw the diagram. After that you can ask me doubt. N is replaced by N cos theta and N sin theta. There is another one F. F is replaced by F cos theta and F sin theta. There is a friction here. Friction F is replaced by F cos theta left side and F sin theta downward. I am drawing all the forces acting on the car. The frictional force has two components, F cos theta left, F sin theta down, drawn. Any other force, then mg is there, downward, mg, weight. weight is there, mg. It is downward, right? mg. So any other force? There is another force. I will explain it after that later. The centripetal force is there. I will explain, don't worry. So far all the forces are marked, right? N sine theta, n cos theta marked. N is replaced by n cos and n sine. F is replaced by f cos and f sine. Mg also I marked. So all the forces I marked. And listen, there is an excess force towards left. It is said to be the centripetal force. I will tell you, don't worry. I will tell you the centripetal force. So this diagram is clear. This diagram is clear. Please respond.
sir.
So this diagram is clear. So this car is in equilibrium. You agree with me? Sorry, this car in equilibrium means that is this car, whether this car moving up or down? Please tell me, is the car moving up or down? Is the car moving up or down? You please respond. No, the car is not moving up, not moving down. So the vertically the car is in equilibrium. Can I say like that? The car is neither moving up nor moving down. The vertically the car is in equilibrium. Vertical motion is not there for this car. So what I can say? Total upward force, which is n cos theta. Total upward force is equal to total downward force. Is it okay? All of you clear? Understood?
Yes.
Yes, sir.
So because the total upward force is equal to total downward force. So this step is clear. And in the towards left, there is no, I mean, only left forces acting only in the left side direction. Understood? The forces acting only in the left side direction. So the total force acting to, let it be equation number 1. Okay, let it be equation number 1. And also remember in the previous class, okay, let it be equation number 1. Normal reaction has a formula. I will discuss later. I discussed in the previous class. Now listen. Now listen. The total force towards left. What is that? The total force towards left. Let me write it in sentence. Total force towards left. Towards left side, right? Yes. What is that? F cos theta is acting towards left and n sin theta is acting towards left. Is it correct? You please respond. Is it correct?
Yes, sir.
Yes, sir.
So there is a net force towards left. There is a net force towards left which is not cancelled. Is there any force towards right? No, there is no force towards right. So you may be wondering, there is a net force towards left, but the car is not moving towards left. There is a net force towards left. So what I am saying is, there is a topic centripetal force which is there in the chapter number 3, motion in a plane. There is a chapter motion in a plane. In that chapter there is a topic circular motion. In the third chapter there is a topic circular motion. In that circular motion topic there is a force mentioned, centripetal force. What do you mean by centripetal force? I will give you a rough idea. All of you please listen. I have a rope. I have a rope. A stone is attached at the other end of the rope and I am rotating this. I am rotating this rope, the stone, with the help of a rope. I am holding with my hand. This one I am holding. I am rotating this. So every time if it is rotating, I am applying a force towards the center. Understood? I must apply a force towards the center. Then that force keep the body rotating in the circular path. If such force I am not applying towards the force, if that force is not applied, this body will escape. This body will escape from the track, circular track. So some force should be required towards the center. So if I am rotating a body with the help of a rope, every time I am applying a force towards the center. That force is necessary, otherwise it will escape from the circle. So that center, the force towards the center, it is said to be centripetal force. You will learn in detail in the third chapter. So centripetal force is okay, clear. It is a force required to, it is the force towards the center to keep the body moving in the circular track. Understood? Clear?
Sir.
So you may write a note somewhere, the centripetal force, you may write it somewhere. You will learn in detail in third chapter. Centripetal force has a formula. Suppose the stone is moving with a speed v. Suppose the stone is moving with a speed v and the stone has the mass m. I will clarify all your doubt, but listen. The stone has the mass m moving with a speed v. The radius of the circle is r. Centripetal force is mv square by r. Okay, for the time being you memorize this. Its derivation is there in the third chapter. In the third chapter we will learn the derivation of this centripetal force. So I will repeat. Centripetal force is for the circular motion. For example, a thing like this. A stone is attached to a rope and I am rotating this stone with the help of a rope. To keep the stone on the rope, I am every time during the rotation, every time I am applying a force towards the center. Otherwise it will escape from the circle. Every time I am applying a force towards the center. That force is said to be centripetal force. Formula memorize right now. mv square by r. M is the mass of the body moving in the circle. V is the speed of the body. R is the radius. So for the time being memorize this formula. Centripetal force. All of it clear? Understood? Okay.
Yes, sir.
Okay. So what is the net force acting towards left? F cos theta plus n sin theta. Understood? What is the use of the force acting towards left? Is there any purpose? Is there any purpose? All these forces contribute the centripetal force. Total sum of these two towards left, this contribute the centripetal force. Why there is centripetal force? You know that this car is taking a turn. Understood? It's very difficult for me to draw the diagram. Is the car taking a turn? You agree with me? It's a turning actually. Okay, the car is taking a turn. Let me draw another color. The car is taking a turn like this. So it's a part of a circle. Understood? The car is moving along a circle. You agree with me? Please respond. Is it correct? This car is taking a turn. So during the car taking a turn, the car is actually moving in a circle. Understood? Arc. This is arc. Moving along a circle. So the car is under circular motion. So a force is required towards the center. If you enlarge the circle look like this. So a force towards the center is required. This is the center. Centripetal force is required. Otherwise the car will not remain in the circular track. The car will not remain in the circular track if the force towards the center. If you complete the circle, there will be some center here. Some force, some kind of force is there towards the center. That is why the car lies in the circular track. So that which one contribute this centripetal force? N cos theta plus F cos theta. This total force towards the left side contribute the centripetal force. Understood? Okay, clear? You understood? Okay. So what is the centripetal force? Centripetal force is, I have written the formula. Mass of the car is m. Mass of the car is m. Speed of the car is v. Radius of curvature will be there. Radius of curvature, let us assume that it is r. Radius of curvature, let us assume that it is r. You may zoom the diagram. I got another equation. After this, if you skip some steps, no problem. Okay. In exam point of view, you must draw this diagram neatly and you have to write some 3 or 4 steps. After that, if you write substituting this in that and we get, you will get the mark, no problem, but the important steps should be there. Okay, so I got two equations not completed, one more equation. In the previous class we studied formula. This car lying on the inclined plane, Aryan doubt ഒക്കെ ചോദിക്കാട്ടോ, ഒരു മടിയും വേണ്ട. This car lying in the inclined plane, you agree with me? This car lying in the inclined plane. So what is n? Tell me. This car lying in the inclined plane. So 1 minute. Yes, this car is lying in the inclined plane. So you studied that n equal to normal reaction equal to mg sin theta, sorry, mg cos theta. I explained in the previous class. I have written it as a note. I don't know whether you remember or not. I explained in the previous class. Look here. Not this one. Yes. In the previous class, I have written it as a two cases. In the horizontal plane, normal reaction will be mg. In the inclined plane, if you resolve, you can understand that. I explained in the previous class. In the previous class, I explained that the normal reaction equal to mg cos theta. You may refer your notebook. You can see that. In the inclined plane, normal reaction is mg cos theta. Okay. So we studied that in the previous class. Normal reaction, if the car is lying in the inclined plane, normal reaction is mg cos theta. So mg cos theta is okay. Now listen, not completed. And friction. 1 minute. No problem. This step is not required for us. Even if you write the step, no problem. We can avoid that step. If you without that step, we can find it. The friction. In the previous class, we studied friction. What is the friction? Do you remember? What is the friction? Nadasha, Rakshana, Aaron. What is friction? We studied in the previous class the friction. Look at this. Friction is given by mu Sn. We studied the friction is equal to mu into n. N is the normal reaction. Whether the body lying in the inclined plane or horizontal plane doesn't matter. The friction is given by mu S into n. The car is not moving, not sliding. Understood? The car is not sliding. In the inclined plane. In the inclined plane, the car is stationary. I am saying in the inclined plane. In the inclined plane, the car is not skidding, not moving. So in the inclined plane, the car is stationary. So this friction is equal to, we studied in the previous class, the friction is equal to mu S into n. We studied that. The friction is equal to mu S into n. Mu S is the coefficient of static friction. Why static? Because is the car moving along the inclined plane? Is it skidding? No, it is not moving in the inclined plane. In the inclined plane, the car is stationary. So the friction, the car is not moving, so the friction is said to be static friction. Not moving the car in the inclined plane. So the friction is equal to mu S into n. N is the normal reaction. Mu S is the coefficient of static friction. You can avoid a few steps, that doesn't matter. You have to write you have to write the reason properly. Okay, from 1, 2 and 3 we can find the formula of V. We can derive the formula of V. If you skip that step, no problem. The sufficient steps are necessary. So till this step you are okay? Understood? Please respond. Till this step you are okay?
Yes, sir.
Okay.
Yes, sir.
I will write some 1, 2 or 3 steps, but it is not necessary to write all the steps. So let me write that equation once again. N cos theta equal to, okay. The first equation is what? N cos theta equal to, tell me. F into sine theta. F is mu Sn. Understood? Can I substitute F as mu Sn? No problem. F is mu Sn. F is mu Sn into sine theta plus mg. Equation number 1. And second equation is F cos theta is there. F is mu Sn. F is mu Sn. Mu Sn cos theta. Mu Sn cos theta. I'm just copying that. Plus n sin theta. N sin theta. Is equal to mv square by r. What is my objective? I want v, the velocity, the maximum velocity. So after that, some steps you may skip it, but I will tell what is to be done. From the first equation, we get the value of n. If you do the rearrangement, I don't want to show all the steps because we have already written the enough steps. We have already written the enough steps. I am explaining exam point of view. Okay. If you do the rearrangement and make the arrangement, definitely you will get the value of n. But that step I am skipping. If you do the rearrangement, definitely you will get the value of n. Definitely you will get the value of n. That n to be substituted here. From first equation, do the rearrangement, you will get the value of n. That value of n to be substituted in the second equation, you will get v. You will get the value of v. So that step I am skipping. You don't worry, you will get the mark. Okay. I will write the step here. From 1, we get n. We get n. Then substitute. Into. Substitute the value of n into. Okay. Then substitute the value of n in equation number 2. We get the formula. V square equal to mu s plus tan theta. Some 3 or 4 steps are there, but you may skip that, no problem. Mu s plus tan theta divided by 1 minus mu s tan theta into Rg. Or taking square root, the V is V max, okay? Maximum velocity, okay? Let me write here. Maximum velocity. Save speed or save speed. The car should be, the velocity of the car should not exceed a limit. The maximum velocity of the car, V, is given by taking square root. This formula you have to memorize. Mu s plus tan theta. Here 2 or 3 steps I have not discussed, but don't worry, if you skip that step you will get the mark. If you definitely need that step, I can discuss right now. If you ask me, I can discuss that. Rg, it will be inside the square root. You have to memorize this. This formula you have to memorize. There are questions based on this formula. So I have written the sufficient steps here. Okay. So all of you please write down. If you want some 2 or 3 steps I missed, if you really need, I can discuss right now if you need. All of you please write down. All of you please read from beginning. All of you please read from the starting. If you don't understand any step, please ask. Maximum velocity of the car is root of mu s plus tan theta by 1 minus mu s tan theta Rg. Who is absent in the previous class? Previous class, Nadasha ഉണ്ടായിരുന്നോ കഴിഞ്ഞ ക്ലാസ്സിൽ? ഫ്രിക്ഷൻ എടുത്തപ്പോൾ ഉണ്ടായിരുന്നോ?
ഇല്ല സർ.
ആ ഇല്ലായിരുന്നു അല്ലേ. ഓക്കെ ഓക്കെ. എല്ലാം ഞാൻ ഇവിടെ എല്ലാം ഇവിടെ സേവ് ചെയ്ത് വെച്ചിട്ടുണ്ട്. ഞാനൊന്നും സെർച്ച് ചെയ്യട്ടെ കേട്ടോ. ഞാനത് അപ്ലോഡ് ചെയ്തിട്ടില്ല. ഞാൻ ഏതായാലും റെഡിയാക്കിയേക്കാം നടാഷ.
എക്സാം ആയിരുന്നോണ്ടാ സർ വരാത്തെ.
ഓക്കെ. All of you please read from the beginning. Please clear all your doubts right now. Okay. ആര്യൻ എന്തെങ്കിലും ഡൗട്ടൊക്കെ ഉണ്ടെങ്കിൽ ചോദിക്കാം കേട്ടോ. ആര്യൻ ഒരു ഡൗട്ടും ചോദിച്ചില്ല എൻ്റെ അടുത്ത്. ആര്യൻ
Okay, sir.
സ്റ്റാർട്ടിങ് മുതൽ വായിച്ചു നോക്ക്. ദേവ ക്യാൻ ആസ്ക് മീ ഡൗട്ട്. ദേവ.
Okay, sir.
This chapter is almost finished. Only 15 or 20 minutes is required. I mean 2 or 3 problems I want to discuss. Two problems I want to discuss. The chapter is over. Okay, chapter is over. There is a question based on this formula given in textbook. I will discuss in the next class. Chapter is, yes, over. Chapter is over.
So can you explain last step again, that how we got V square?
Okay. If you want this intermediate steps, I will discuss right now. From one, it is a boring step. That is why I did not discuss that. Okay. Those who are interested in the missing steps, you can listen, or else you can skip some 3 or 4 steps. You will get the mark. Aaron, I will discuss that. Okay. That missing steps, I will discuss that. Okay. Okay, understood. So listen, please listen. It is actually a little bit boring, but listen. From 1, Aaron, can I take this term to left hand side? Aaron?
Yeah.
Yes. N cos theta, this mu s n go to left hand side. Equal to mg. Is it correct? Aaron, this mu s n sin theta taken to left hand side. What I have written, from 1 we get n, right? Yes. Here, all of you please listen. I am writing the missing steps. Okay. N is common in left hand side. Is it correct? Understood?
Yes, sir.
N is common in left hand side. N is taken out. N into cos theta minus mu s sin theta is equal to mg. Is it okay?
Yes, sir.
What is n then? What is n? N equal to mg divided by. N equal to mg divided by cos theta minus mu s sin theta. Please respond. Is it okay? Aaron, Aryan, Rakshana. Is it correct? Yes. N equal to this. I got the value. Whatever I have written, I have done here. From 1 we get n. Yes, from 1 I got n. Now I am going to substitute n in the second equation. I am going to substitute the this n in the second equation. What is the second equation? Mu s into n cos theta. Okay, before that, in the second equation, this n is common. In the second equation is n is common. Let me write, first of all, let me take n outside. In the second term, equation n is common. Can I take n outside? Yes. Mu s cos theta plus sin theta is equal to mv square by r. I got this equation. So can I do? I can do one thing. This v, sorry, not v. Sorry. M by r is there in the left hand side. Can you see m by r in the right hand side? M by r. Please respond. That m by r can be transferred to left hand side. This m by r can be transferred to the left hand side. Yes. So what happens? V square equal to what? This m by r becomes r by m in the left side. r by m into n is there. R by m will be there and n is there. What is this n? mg by this one. Mg by, you can zoom it. You can zoom it. You can zoom it. All of you please zoom. M by r taken to left hand side. V square equal to r by m will be there. N is there. And mu s cos theta plus sin theta will be there. Mu s cos theta plus sin theta will be there. I will write the next step, next page. Anyway, this step is clear to you? Rakshana, Aaron, Aryan, Nadasha. Is it okay? Please respond.
Yes, sir.
Please tell me. M by r taken to left hand side. V square equal to m by r becomes r by m here.
Yes, sir.
Okay, understood. Mg, n is written.
Sir.
Tell me. What is your doubt? Hello? Any doubt? Hello? Please respond. Any doubt? Nobody is responding. All of it clear? Hello? Hello? Are you listening?
Yes, sir. Yes, sir.
A doubt, sir.
Doubt. Okay, doubt. Yes. Let me write the last step once again. Okay. Deva, Aaron, ഒരു minute wait കേട്ടോ Aaron. Deva, have you understood this step?
Yes, sir.
Deva, Aaron, ഒരു minute, 1 minute. Deva, have you understood this step? Have you understood this step?
Sir.
Sir, I'm having a doubt, sir.
Not voice is breaking. Can you repeat?
Sir, I'm having a doubt, sir.
You are having doubt. Which part you have a doubt? Please tell me.
N is equal to mg by cos theta minus mu sin theta, sir. The next step, sir.
Next step. Next step. Listen. The second equation. All of you please listen. The second equation is there. Understood? The second equation you see Deva, n is common. Is it correct? In the second equation n is common. Is it correct? Please respond.
Yes, sir.
Never all of you please listen. Never, don't leave my class. Let me complete the derivation. Okay. In the second equation n is common. So I have taken n outside. That is written here. Here n is common. N is taken out. So if n is taken out, mu s cos theta plus sin theta is remaining. N into mu s cos theta plus sin theta equal to mv square by r. Is it okay? Clear?
Yes, sir.
Now, this step I have discussed some 3 or 4 times. This m by r is there. I have highlighted it. Can I take this m by r to the left hand side? Because I want v square. Because I want v square. Safe velocity. I want v square. So this m by r taken to left hand side. So this m by r becomes r by m in the left hand side. So v square is there in the right hand side. So v square equal to this m by r taken to this side becomes r by m. Into n is there. Into n is there. What is n? N is mg by this. So this n is written as mg by this one. The denominator is minus, sorry. So n is mg by cos theta minus mu sin theta. So n is written as mg by cos theta minus mu sin theta. Sorry, I made a mistake here. I will write it once again, no problem. Let me write the second equation once again. Boring ആയിട്ട് തോന്നല്ല കേട്ടോ. Okay, don't feel boring. Let me complete it. Let me write the last equation once again. N into mu s cos theta plus sin theta equal to mv square by r. this m by r taken to left hand side. So v square equal to this m by r becomes r by m. N is there. Mu s into cos theta plus sin theta is there. Is it okay? All of you please respond. Aryan, Rakshana, Deva. Is it okay?
Yes, sir.
V square equal to r by m into n. What is this n? What is this n? N is written as mg by cos theta minus mu sin theta. Mg by cos theta minus mu sin theta. Mg by cos theta minus mu sin theta. Into mu s cos theta plus sin theta. Okay, never leave my class. Let me complete it. Let me complete it. I am writing all the steps. That is why it is lengthy. I am writing all the steps. That is why it is appeared to be lengthy. Is it okay? All of it clear?
Yes.
Yes, sir.
Now this m and m cancels. M and m cancels. Now we get the answer. Some 2 or 3 steps again. V square equal to r into g is there. Can you see that? R into g. What is next remaining? In the numerator side, mu s cos theta plus sin theta is remaining. And in the denominator side, cos theta minus mu sin theta is remaining. Is it correct? Please respond. Rakshana.
Yes.
Okay. But our answer, I want the answer in terms of tan theta. Look at this formula, final formula. I want the answer in terms of tan. I want tan. You studied basic trigonometry.
Sir, we divide by cos.
Yes. It is basic trigonometry. You studied in 10th standard. Basic trigonometry. If I divide numerator and denominator by cos theta, that does not affect this fraction. Numerator and denominator divided by same number does not affect. Mu s cos theta by cos theta. Cos theta will be cancelled. Mu s. Sin theta by cos theta. Tan theta. Cos theta by cos theta. 1. Mu into sin theta by cos theta. Mu into sin theta by cos theta tan theta. You may write all the steps. Anyway, some steps you can skip. Okay, taking square root of rg into. Actually, the derivation is there in our syllabus. We cannot skip it. Mu s plus tan theta divided by 1 minus mu s tan theta. This formula you have to memorize. There are questions. V is the maximum speed or space safe speed. The car speed should not exceed this limit. Otherwise, the car will skid away from the track. Okay. So all of you please write down. You please read from the beginning. If you have any doubt, you please ask. Aryan, okay, le Aryan.
Yes, sir.
Rakshana, Deva, Nadasha, please ask your doubt.
Sir,
Tell me.
understood, sir.
Understood. So the remaining part, I mean 2 questions are remaining in this chapter. I will discuss in the next class. Okay. So let me stop the class. Only this derivation is taken today. Okay. So if you have written and if you don't have any doubt, you may leave the class. If you have any doubt in any step, you please ask.
Sir, all understood.
Okay. Then you may leave the class. Okay. Okay. Bye.
Thank you, sir. Bye.
Thank you, sir. Bye.
Okay then.
Sir,
Yes. Tell me.
sir, can you send the PDF of this PPT, sir.
PDF I will send. No problem. I will send it. Okay.
Okay. Thank you, sir.
Okay.
Bye.
Okay. Bye.